Today we're going to learn about Lewis structures. Specifically, we're going to learn about Lewis structures of molecules. All right, remember that covalent bonding is between two nonmetals. Nonmetal two nonmetals. They share valence electrons, and we must remember that the valence electrons are the outermost electrons, the ones involved in chemical bonding. The octet rule means that all atoms want to have 8 electrons. So it's important to remember that we want 8 electrons, with the exception of small atoms, such as hydrogen, that can only take 2 electrons. And there's another exception, that is boron, that can only take 6 electrons. But other than that, everything wants 8 electrons in its outermost energy level. There's something else to remember. There are multiple bonds sometimes. There's single bonds represented by 1 dash, which is equal to having 2 electrons being shared. There is double bonding represented by 2 dashes, and that means that 4 electrons are being shared. And finally, there are 3 triple bond. So single bond, double bond, and triple bond, and that represents that there are 6 electrons being shared. Lewis structures is basically how atoms come together to form molecules. And we have to take into account all these rules that we learned in order to be able to write these Lewis structures. We already know how to write the Lewis structures for atoms, such as chlorine having 1, 2, 3, 4, 5, 6, and 7 electrons in the outermost energy level. Now we're going to move on to building molecules, atoms that come together to form neutral molecules. All right, let's take a look at the rules. And at this point, I'm going to ask you to make sure that you have, of course, before you begin, you should have your journal, and you really need to copy these rules. So pause and go ahead and copy the rules of writing the Lewis structures. We're going to go ahead and start some examples, and we're going to write the Lewis structures for some molecules. And we're going to follow the format. Notice that I've written here the basic rules, the basic steps that you just copied. I'm going to begin with a simple molecule, HCl. And I write the formula, and I'm going to find out first how many total valence electrons each one of these has. We know that hydrogen, if you look at the periodic table, it's in group 1. It's 1 valence electron. And chlorine has 7 valence electrons. And that gives me a total of 8 valence electrons. All right, so then we are going to take the next step and determine there's no central atom here. When there are 2 molecules, you don't have to worry about central atoms. But normally what you do, and you have to make note of this, that when you have several atoms and you need to determine the central atom, you're going to go put the central atom, that one atom that it has the lowest electronegativity, except in the case of hydrogen. Hydrogen can never be a central atom. All right, so in this case we have no central atom, and we have HCl. All right, so HCl is our bond. We have established that there's 2 electrons being shared here. Each dash represents 2 electrons. So now I'm going to subtract these 2 electrons. So subtract the 2 valence electrons that I have already placed, and that gives me 6 electrons left to be placed. So I'm going to go ahead and place them Cannot place them around the hydrogen because hydrogen cannot hold more than 2 electrons, but I'm going to place them around the Cl, and that is it. This is our Lewis structure for hydrochloric acid. All right, let's try a second example. NF3. First of all, we're going to determine the total number of valence electrons. So we have 5 valence electrons for nitrogen. If you look at your periodic table, you can determine that. Fluorine has 7 valence electrons. However, it has 7 valence electrons, but there are 3, so we have to multiply this number. 7 times 3 is 21 valence electrons, plus 5 that nitrogen has. That gives us a total of 26 valence electrons that need to be placed. Then I'm going to go ahead and write the central atom. My central atom is going to be nitrogen. Between fluorine and nitrogen, nitrogen is the lower electronegativity, so I'm going to place nitrogen in the center. Then I'm going to go ahead and bond the rest of the atoms. Fluorine, there are 3 fluorines, so I'm going to have 3 fluorines placed like so. And I'm going to then go ahead and determine how many electrons I've already placed. With each dash represents 2 electrons, so 2, 4, 6. 6 electrons have already been placed. So we don't have to worry about those, but we're going to subtract, and this gives us 20 electrons, valence electrons left to be placed. So now I'm going to go ahead and start placing them. I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 electrons. And there are 2 electrons that I must still place. And we check, everybody has an octet. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8 electrons. However, nitrogen has only 2, 4, and 6 electrons around it. So this is the place where I'm going to put the remaining 2 electrons. And this gives us a molecule that is correct as far as the Lewis structures. There are other cases where atoms have to share more than 1 pair of electrons. And we're going to start out with this example. We're going to start out with N2. The first thing I have to do is to place, first of all, let's count the number of electrons. So I was jumping the gun there a little bit. There are 5 valence electrons times 2. Therefore, there are a total of 10 valence electrons for this molecule. And I'm going to go ahead and write NN. This is the only way to attach them. And this, of course, represents 1 pair of electrons, 2 electrons being shared. So we represent it with dashes. Now, once I do that, I can subtract 2 electrons, 2 pairs of electrons, and this gives me 8 electrons left to be placed. A little tight there in space. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8. And this is where we say, Houston, we have a problem. Ask me about that in class. I'll tell you what that means, in case you haven't watched Apollo 13. If not, you know what I'm talking about. 2, 4, 6, 2, 4, 6. The problem is right now that neither of these atoms have an octet. So therefore, we have to fix that problem. So the way we're going to fix it is this nitrogen is going to say, oh, I'm a nice guy. I'm going to go ahead and let you, I'm going to share this other pair of electrons. So I'm going to place my pair of electrons here. And it says now we have 2, 4, 6, 8. And that's perfectly happy. 2, 4, 6, very unhappy nitrogen. So this guy on the right is going to say, hey, I'm a nice guy, so I'm going to share 2. And now we're going to go ahead and place this pair of electrons here. And this is what we call a triple bond. And this molecule N2 is correct. It is our Lewis structure for nitrogen. Let's try another example. And this time we are going to try carbon monoxide, CO. Again, we are going to determine how many valence electrons, and nitrogen has, I'm sorry, I'm still in the last example. Carbon has 4 valence electrons, and oxygen has 6 valence electrons. So we're going to add these up, and we are going to determine that we need 10 valence electrons. So we have 10 valence electrons amongst them. So we're going to draw a structure. And next, we are going to subtract these pair of electrons we have already placed. 2 valence electrons. We have 8 valence electrons left to be placed. I am going to go ahead and start putting them up there. 1, 2, 3, 4, 5, 6, 7, 8. And again, what do we say? Houston, we have a problem. 2, 4, 6, 2, 4, 6. We do not have an octet, and we're seeking an octet. So again, we're going to have one of the kind atoms share a pair of electrons. So I'm going to go ahead and say that carbon is going to be kind enough to share its pair of electrons. So, or let's say oxygen here will remove this pair of electrons, and it's going to share very nicely here its pair of electrons. And 2, 4, 6, 8, 2, 4, 6, still not an octet. So I'm going to repeat the process. This guy is going to say, okay, I'm a nice guy. I'm going to go ahead and erase this pair of electrons. And now I'm going to be kind enough to share it. Oops. Let's get my pencil back and put that there. Actually, I should have put these 2 dots over here, but that's okay. It's still correct. Let's see. We have 2, 4, 6, 8, 2, 4, 6, 8, and the Lewis dot, preferably it would be C3, 2 dots here and 2 dots over here. We try to spread them out as far away as we can. Now, don't think that all the examples would have 3 bonds. There are some that have only 2. A quick example that I can show you is O2. And again, we're going to figure out the number of valence electrons, 6 valence electrons each. That's a total of 12 valence electrons. So I'm going to start with single bond there. Subtract the 2 valence electrons that I've already placed. Remaining 10 electrons, valence electrons to be placed. So that's 16 is the 10. And I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So here we have a problem again. This atom is perfectly happy, satisfied, totally content, but this one's not because it does not have an octet. So I'm going to go ahead and fix the problem again. Use my trusty eraser here. This guy's going to share its electrons, and it is happy to do that. And oops, I need a pen again. And those 2 electrons that I erased, they're going to go here in sharing, and 2, 4, 6, 8, 2, 4, 6, 8. Everybody's happy, and we can move on. All right, so the last example that I have for you is the polyatomic ions. So polyatomic ions are interesting because they bond with metal, and they form ionic bonds or ionic compounds. However, within the polyatomic ion, the polyatomic ion itself is covalently bonded within the polyatomic ion they're sharing. Remember, like PO4, 3 negative, and so on and so forth. But let's do this example, CN. And I'm going to go ahead and follow the same format. We know that carbon has 4 valence electrons, and nitrogen has 5 valence electrons, and that gives me a total of 9 valence electrons. However, I have to add one more because notice there's one more electron here. It gained an electron, so I'm going to add one more electron, and that gives me a total of 10 valence electrons to be placed. And I'm going to go ahead and draw my initial diagram, and I know that this represents 2 electrons, so 2 valence electrons, 8 valence electrons, and this means that I have to place 8 electrons. So I'm going to start out with 1, 2, 3, 4, 5, 6, 7, 8. All right, and we have placed our 8, but we don't have an octet. Problem. So 2, 4, 6, 2, 4, 6, no valence electrons. Again, this happens to be one that has double bonds or multiple bonds. So I'm going to have to go ahead, erase a pair. Nitrogen says, I'll be a nice guy, and I will share my electrons. So those we erase, and we come back here and place those that we erased here as sharing electrons. And we have 2, 4, 6, 8. Carbon is perfectly content. 2, 4, 6. Nitrogen is not, but carbon is nice enough to say, okay, I'm going to be a nice guy. I'm going to share so that everybody can be happy. So here we go. We erase. We come back over here, place that bond here, and we have a perfect formula, except that since this is an ionic compound, I'm sorry, a polyatomic ion, we have to put a bracket around it, and we have to put a minus here so that we know that we added one more electron over here to the total number of electrons. And this tells us this is a polyatomic ion. All right, and that's all of the examples, and more practice in class.